Okay, so we're going to jump into rational inequalities then. So rational inequalities, a bit of a step up then from our quadratic inequalities. We're using a lot of the same ideas though, so kind of that basic idea of what an inequality is obviously still going to apply. I suppose the difference comes in terms of rational versus quadratic, I suppose really. So rational inequality refers to rational, that idea of fraction. Okay, so think of a rational number. A rational number is a number that can be written as a fraction. So rational inequality is an inequality where our expression there is going to involve a fraction. So an example there is our 3x minus 2 over x plus 1 is greater than or equal to 2. So that's an example of a rational inequality. And I suppose one of the key differences with these questions is because we have our inequality sign, we should remember that if I multiply by a negative number, so say for example 4 is greater than or equal to minus 3, if I multiply by a negative number, then I must flip my inequality sign. Okay, then I have to flip my inequality sign. But with these rational inequalities, we see that we have an expression on the bottom, x plus 1, and we can't be sure whether that is positive or negative, because obviously that's going to depend on what the value of x is. So for that reason, we can't just multiply both sides by x plus 1 to solve this inequality. And instead, we're going to multiply by x plus 1 squared. So we multiply by the denominator squared. So our steps in solving, fairly straightforward once we have the quadratic ones down. We're going to multiply by denominator squared, and then we solve as a quadratic inequality, as before. Okay, so this is kind of what I mean, I suppose, when I say that it's a lot of kind of just a step up from our quadratic ones. We're using a lot of the same ideas that we have already. So let's jump into the first question here, I suppose. So 2x plus 4 over x plus 1 is greater than 3. So following that same idea that I've just kind of said there, I suppose, we have x plus 1 in the denominator there. And in theory, what I'd like to do here is just multiply across by x plus 1 to get rid of the fraction. But I can't do that because I can't be certain that it's going to be positive. If it was negative, I would have to change the sign. So I want to multiply by something that I'm sure of, that I won't have to change the sign for. And by squaring that denominator, I'm certain it's going to be positive. Because remember, anything squared is going to be positive. So in doing that, it means I definitely don't have to change my denominator. But by looking at here, we have x plus 1 on the bottom, we have x plus 1 squared up here, so the x plus 1 on the bottom will cancel out the squared part and just leave me with 1 x plus 1 there. So I get the same result. I get rid of the denominator part there, which is kind of my real goal. Then we can use that then in multiplying out the rest of this. So let's just sort all of this out. 4x plus 4 is greater than 3x squared plus 6x plus 3. So let's just bring everything to the same side here. So minus x squared minus x squared minus x squared plus 1 is greater than 0. What I'm going to do here is I'm going to multiply by minus 1 so that I can just have my inequality looking a bit more like something that I'm used to. So x squared minus 1, and I will have to flip the inequality sign there because I've multiplied by minus 1 across there, so both sides. So looking at this now, we're just going to solve it like a quadratic inequality. The first thing we do is we find the roots, so we let it equal to 0. X squared minus 1 equals 0. That's an example of a difference of two squares. So we get x equals 1, x equals minus 1. If I sketch my graph here, my two roots, 1 and minus 1. And now I need to look at my inequality. So my inequality here tells me it's less than 0. So I'm looking at the section below the x-axis, which means x is going to be between those two values of 1 and minus 1 there. So the same idea that we've seen, you can kind of see there, nothing really particularly new coming in, barring these first kind of two lines. So multiplying by the denominator squared and then rearranging your equation to get your quadratic inequality as before. So let's just jump straight into the exam questions here, because this was from then on, it's really just the same idea. So 2x minus 3 over x plus 2 is greater than or equal to 3. So same idea as before, we're going to be multiplying by the denominator squared. So that's going to give me 2x minus 3 by x plus 2 is greater than or equal to 3 by, let me square this out, x squared plus 4x plus 4. So then multiplying this part out, 2x squared plus 4x minus 3x minus 6 is greater than or equal to 3x squared plus 12x plus 12. Okay, simplifying this as before, I'm just going to bring everything to one side. So minus x squared plus x plus 12, so that's minus 11x, and minus 18 greater than or equal to 0. If I want to get all of this kind of as normal here, I'm going to multiply across by minus 1 to give me x squared plus 11x plus 18 greater than, or I need to swap my inequality sign here because I've multiplied by minus 1. So I'm multiplying across by minus 1 there, so I need to swap that inequality sign. Now I'm solving as a quadratic one, so I let it equal to 0 to find the two roots. So two numbers that will multiply to give me 18, but add to give me 11. That's going to be 9 and 2. So my two roots are minus 9 and minus 2. And again, I can sketch my graph as normal. So minus 2 here, minus 9 here. Looking at my inequality, I'm looking less than or equal to 0. So I'm going to be using the section below the x-axis there. So that's the values between minus 2 and minus 9. So you can kind of see here how it keeps coming back to the same things we did with the quadratic in the last video there. So making sure you can identify which region you're looking at. So less than 0 below the x-axis, greater than 0 above the x-axis. So let's look at another question. Okay, a similar enough one here, but this time just noting that we have a different inequality sign. So we're facing the other way, and also we have a kind of second fraction to deal with here. So just some extra added parts to kind of contend with for us. So we get 2x minus 5 times x minus 3 is less than or equal to 5 over 2 times x squared minus 6x plus 9. Okay, what I'm noting here is because I have a fraction on the right hand side, if I want to get rid of that, I'll maybe multiply across both sides by 2. So multiplying both sides by 2 to get rid of the 2 on the bottom there. So that's going to mean I'm multiplying this left hand side by 2, but let's multiply it out to see what we get. Minus 6x minus 5x plus 15 is less than or equal to 5x squared minus 30x plus 45. Multiplying this left hand side by 2 there, 4x squared minus 22x, okay, just making sure we've got that out completely, plus 30 less than or equal to 5x squared minus 30x plus 45. Okay, let's try and approach this maybe slightly differently this time. So I've been bringing everything to the left hand side, because that's kind of typically what we do. Let's say we bring them all to the right hand side here. I get 0 less than or equal to x squared minus 8x plus 15. Okay, x squared minus 8x plus 15. So let's let that equal to 0 here. So x squared minus 8x plus 15. So two numbers that multiply to give me 15, but will add to give me 8. So that's going to be x minus 5 and x minus 3. So I get x is equal to 5 and x is equal to 3. Sketching my graph as per normal, my two roots, 3 and 5. I need to look at my inequality to see where I'm going to be looking. And with the way we've written it here, it's slightly maybe harder to see. So let's just swap everything around, making sure I keep my inequality facing the correct way. So the big side pointing towards the function. I'm looking greater than or equal to 0. So I'm looking at the two endpoints. So x is less than or equal to 3 and x is greater than or equal to 5. Now this one here, a little bit of a trick one, I feel, in this one, because in most questions we would get a little note here telling us that x is not allowed to be 3 in most questions like this. And the reason for that is because the bottom, the denominator here, is 3 minus 3. So if the x was allowed to be 3 there, that would give us a fraction with 0 on the bottom, and we're not allowed to have that. Okay, we're not allowed to have a fraction where we have 0 on the bottom. So in fact, just I suppose for us to be completely correct here, instead of saying less than or equal to 3, we should probably just say less than 3. But again, something a bit tricky there, something that maybe they haven't made abundantly clear here, but in a question where they maybe do give you that extra note, it's just something to look back for and make sure that both of your solutions are allowed, particularly in these solution sets, that they haven't ruled out one of the solutions already for you. Okay, something similar kind of, I suppose, in the previous one there as well, which I didn't fully note, less than minus 2, and it's allowed to be minus 9. Okay, the same kind of idea happening there. Okay, and we in fact were even given that in the previous one. This x is not equal minus 2 means that the function down here, and I did do it, I just didn't draw attention to it, is less than minus 2. Okay, it's not allowed to be equal to minus 2, but it could be equal to the minus 9 part. So just another thing to watch out for. Okay, I think we have one last question to do. So let's have a look at it. Show that if f of x plus 1 is not equal to 0, then f of x over f of x plus 1 simplifies to x minus 4 over x minus 2. So let's have a look at that. We're going to have to start by getting f of x plus 1. So that means I'm subbing x plus 1 into my function anywhere that I see x. So x plus 1 squared minus 7 by x plus 1 plus 12. So x squared plus 2x plus 1 minus 7x minus 7 plus 12. So I get x squared minus 5x plus 6. X squared minus 5x plus 6. Okay, looking then at f of x over f of x plus 1, I'm going to have two quadratics here. So x squared minus 7x plus 12 and x squared minus 5x plus 6. So that gives me x minus 3, x minus 4, and x minus 3, x minus 2. X minus 3, x minus 2. And we can see there, because I have an x minus 3 on the top and the bottom of my fraction there, that's going to cancel down to x minus 4, x minus 2 as required. For part 2, we need to show the values where this expression here is greater than 0. So from what we did in the first part, we're really looking for where is this expression here greater than 3? Where is this greater than 3? So my first step, as with all the other questions, I want to get rid of the new denominator, but to do that, I have to multiply by the denominator squared, because I can't be certain that the denominator is positive. So I'm accounting for that by squaring it. So that gives me x minus 4 by x minus 2. 3 times x squared minus 4x plus 4. Okay, making sure again that we're all happy with kind of going from, say, this line to this line, that we're making sure that we know because of the x minus 2 on the bottom, that cancels out one of the x minus 2's from the squared part there. So don't go to the trouble of multiplying that out to then realize that you could have saved yourself some hassle there. The whole point of multiplying by that denominator squared is to get rid of the fraction, so make sure that you do. So x squared minus 2x minus 4x plus 8 is greater than 3x squared minus 12x plus 12. So again, as per usual, I'm going to bring everything to one side. I'll get minus 2x squared minus 6x plus 12. So that gives me plus 6x. And the plus 8 minus 12 gives me minus 4 there. Okay, and I want to show where this is greater than 0. Now I'm going to divide across by minus 2 there. So x squared minus 3x plus 2 is less than 0. So swapping my inequality sign because I have divided across by minus 2. Okay, so again, just keeping everything consistent. You could absolutely work away with that quadratic there. I just personally, and I think it's worth for you doing as well, just keep them almost positive if you can. It's easier for you to factorize as well. It looks more like what we're used to. So now let's let it equal to 0. X squared minus 3x plus 2 equals 0. That gives me x minus 2 and x minus 1 equals 0, which means x equals to 2 and x equals to 1. So those are my two solutions there. So going on down then, we can sketch out my inequality here with my two roots, 2 and 1. I wanted to show where my quadratic was less than 0, so that's going to be the continuous range here between 2 and 1. And noting that there's no equals part here, so we don't really have to look for that case of maybe where it's not allowed. For example, in this question, x couldn't be 2. So we're that's already included in our question anyway, but just making a note of it mentally for ourselves. So the key things coming up here with our quadratic inequalities are really, it's this step at the start here, multiplying by the denominator squared. And as I said to you in the first part, they're making sure that we're happy that by multiplying by the denominator squared, we understand this kind of operation here. So how the denominator cancels out the squared part that we're multiplying by and just leaves us with one power, or a power of 1 of that expression there. And that is kind of the whole point, I suppose, of multiplying by the squared of it, is to get rid of the fraction. So if we don't get rid of the fraction, then we've done something wrong along the way there. And then the other thing of just making sure that if they've given you a value in the question that x is not allowed to be, that you account for that if you need to. So the only ones you really need to watch out for that are ones where the inequality here has an equals part. If it doesn't, then you're not going to be including your solutions for x anyway. But just something else to watch out for and to be aware of.